In this lesson, we will learn how to add and subtract numbers in scientific notation. Remember, when we see problems like this, when we're adding numbers with decimals, you have to first line up the decimals. Our problem on the left is written correctly, 12 and 6/10 plus 1 and 5/10 with the decimals lined up. This second example, 12 and 6/10 plus 1 and 5/10 is incorrect because the two decimals are not lined up. So let's cross this one out. Our correct answer would be 14 and 1/10. Now that we remember that we have to line up the decimal when we're adding, let's see how we can use that knowledge when we're working with numbers in scientific notation. When adding numbers in scientific notation, the way you know that the decimals line up is to make sure that the exponents are the same. In this problem, both exponents are 2. So we have to go to our second step, which is just simply to add the coefficients together. 2 and 6/10 plus 1 and 2/10 equals 3 and 8/10. To provide our complete answer, we have to now combine this new coefficient, 3 and 8/10, with the exponent and base we began with. So our solution would be 3 and 8/10 times 10 to the second power, which equals 380. Now take a moment to jot down our notes. You should pause the video and write these down. When we're adding and subtracting numbers in scientific notation, we first have to make sure that the exponents are the same. Then we add and subtract the coefficients. And then our final step is to combine that new coefficient with the same base we started with. Some solutions will not be in proper scientific notation, so you will have this fourth step of adjusting your numbers into proper scientific notation. Let's see what that would look like in an example. Sometimes you'll get problems where the exponents are not the same, like this example. When you look at this example, you see that the first expression in scientific notation has an exponent of 2 and is being added to another number in scientific notation with the exponent of 3. Our exponents are not the same. But if we remember our 2 lessons in our previous unit, we learned how to adjust numbers while in scientific notation. We will be using those rules a lot in this unit. So, if we move this decimal one time to the right, we remember that that will make our exponent one number smaller. So let's see. If I move this decimal one time to the right, our exponent is now 10 to the third minus 1. So our new problem will look like this. Our second expression has now changed to 27 and 1/10 times 10 to the second power. Now our exponents are the same, so we can move on to our next step. Simply add the coefficients. Our solution would be 28 and 36/100. We have to now put that back with our base 10. So our solution is 28 and 36/100 times 10 to the second power. This problem would be correct, but now we have to look at our coefficient. Our coefficient is not a number between 1 and 10, so we have to again move this decimal back. To do this, we have to use our exponent rules again. This was a movement of the decimal left, and we know when we move the decimal left one time, we also have to add 1 to the exponent. So our complete solution would be 2 and 836 thousandths times 10 to the third power would be our final solution. Let's try another example where we have to move the exponent. Here's another example where the exponents are not equivalent. When you look at these two numbers in scientific notation, our first expression has an exponent of 3, and our second expression has an exponent of 4. Remember, before we add, we must adjust the decimal so the exponents are the same. To do so, I'm going to move this decimal one time to the right, and if I follow that rule, that means that this exponent must be subtracted one time. So our new problem will look like this. Our second expression now is 24 times 10 to the third power. Now because our exponents are now the same, we could add our coefficients together, remembering to line up our decimals. Remember that our decimal on our coefficient 24 is behind the 4. So when we line up our decimals here, we'll get our solution 25 and 5/10, which we're going to then multiply by 10 to the third power. When we look at this expression, we notice that the coefficient is not a number between 1 and 10. So now we have to adjust this expression into proper scientific notation. To put this in proper scientific notation, we must move this decimal one time to the left. And remembering that rule, because we moved the decimal to the left once, we now have to add 1 to the exponent. So our final solution is 2 55/100 times 10 to the fourth power. Your lesson check for this lesson is to solve this problem. I want you to give your answer in proper scientific notation and to give me your answer in standard form. When you're done with this lesson check in your community, please check that all 4 of you have the similar answer and then check with your instructor to sign off on your lesson check.